Alrighty, looks like folks are starting to get settled. Numbers not climbing too much anymore, so we'll go ahead and get started. So I'd just like to say good morning and welcome to our third webinar in the Florida-friendly landscaping green stormwater infrastructure series. Just want to let you know that this webinar will be recorded and it will be available online along with the rest of the webinars in the series. Today we're going to be learning about tree boxes and suspended concrete systems. We will hear from experts from Ferguson Waterworks, the University of Florida, as well as the Florida Friendly Landscaping Program. Today's speakers include Jessica Brusso with Ferguson Waterworks, Dr. Eben Bean with the University of Florida, and Claire Lewis with the Florida Friendly Landscaping Program. Additional information about tree boxes and suspended concrete systems can be found on our Green Stormwater Infrastructure Program website. A link to that website will be dropped in the chat box. Next month on May 18th, we'll continue the series and we'll have a webinar focused on pervious surfaces. Attendees can expect an overview of design, technology available, as well as maintenance considerations for pervious surfaces. To see the full lineup of our webinars, including recorded webinars, please visit floridafriendlylandscaping.com and follow the links to the training and FFL webinars. A link will be dropped to that website in the chat as well. This webinar has 1.5 credits for CEUs available for Florida Friendly Landscaping Certified Professionals, FNGLA credits, floodplain managers, professional engineers, and landscape architects. The link will appear in the chat. If you have questions or issues with your CEUs, please reach out to Claire Lewis, and her contact info will also be dropped in the chat. And then additionally in the chat, we'll drop a link to information on green stormwater infrastructure funding information. And just a reminder, if you have any questions for today's speakers, please submit them in the question and answer box as opposed to the chat. That way our moderators don't miss them. We want to make sure we get to everyone's questions. We'll have a little time after each presentation to get to questions, and anything that we don't cover in those time periods, we will save for the end. We have around 10 to 15 minutes scheduled at the end to finish up the Q&A. And with that, I'll turn it over to Jessica Brusso with Ferguson Waterworks to get us started.
Thanks, Nathan. Let me get my presentation shared here and we'll get started on that. All right, so we're going to start here. We are talking about tree boxes and suspended pavement systems today, but I want to give a big shout out to Earth Month. It's April. It's going to be Earth Day soon. What is that, in 2 days now? And Arbor Day is coming up next week. So let's speak for the trees. Trees, I like to consider them our ultimate stormwater BMP. They are something that when we plant them and take care of them appropriately, their value increases as they grow. So we actually get this investment, right, or increased return on our investment. But here is a list of general benefits that we get from trees. So flood reduction, improved water quality, soil and ground stabilization, increased property values. We lower our utility costs. That has to do with our heating and cooling if we are really good with where we put our trees, and temperature moderation as well, which I know is going to be talked about later on a bit more. So we're mitigating that heat island effect, particularly in our urban areas. And we all know, especially here in Florida, that there's a big difference between when we're in a nice shaded area or if we're in an area that's like a desert or walking through like this asphalt desert and it feels like it, right? So not only that, of course, we get oxygen. We know all these things about trees, but we also have these other things that can be quantified, like promoting physical activity and increased well-being. There's definitely lots of studies on that as well. So we have lots to thank for trees. They intercept a lot of stormwater. They uptake through their roots. They intercept water through their leaves. And we'll talk about that later on too. I think Claire's going to talk about how important that canopy is on the trees, and it can be important to choose your trees wisely when planting them. There's ranges out there. There's so many studies that have been done on how much stormwater is intercepted by trees. One study I found said even 20 to 60% can be intercepted by the canopy. And there was this correlation, or maybe not correlation, but they found something between the leaf area index and how much water is able to be intercepted, which makes sense if you have a broader leaf. And that's why we don't talk about palm trees as much here, or we won't today really when we're talking about stormwater BMPs. I wanted to bring this up. I don't know if you guys have seen this at all, but I really love it. New York City has done a fantastic job with green stormwater infrastructure in general, but also with their trees. I put the website up there for you guys to check out. So the tree map, New York City tree map, it was done in the 5 boroughs of New York City, where they are actually tracking the trees that are planted. It's really cool. You can zoom in on a borough. You can zoom in on particular neighborhoods within that borough. There are to date 868,741 trees on this map, including 537 different species. So as you go through, you can check it out. People can favorite their trees. So there's favorited trees in there. They record actions taken as well. So basic actions, things like, watering or changing mulch out or adding soil, to more kind of advanced actions, which would be things like pruning the trees, tree removal sometimes, or tree planting. So really cool interactive thing. I suggest you guys check it out. If anyone knows of anything like this in Florida, I would love to hear about it. I don't know of any yet, but they might be out there. So if there's not, then maybe we can all work together to kind of get this started somewhere. And not only that, the ecological benefits as well. So here's the really, really cool part is you can go to this map and you can see the approximation of how much stormwater is being intercepted that year. Not only that, but what the value equates to. So this is at dollars and cents. We really want to get down to why green stormwater infrastructure is important. A lot of us here, we're like, yeah, environmental benefits, fantastic. However, everyone else up the chain, maybe not everyone, but most people want to know, what is that value? What's the actual monetary value? How can we portray this like this is a great benefit? And here's why. Dollars and cents, right? So we can see the stormwater intercepted, we can see energy conserved, air pollutants removed each year, and then total value of annual benefits. This is annual, right? Overall. So this isn't just, all 10 years or whatever it's been. This is every single year. So a lot of times this is what we want, right? If we're in an urban area, we would much rather be walking underneath these gorgeous trees in some nice shade, especially when it gets hot, than kind of just this barren landscape, right? However, most of the time what we get are these very sad, struggling street trees, or no tree at all. It tried, there used to be a tree. So a lot of times what they call these kind of methods of planting, kind of these just coffins, like tree coffins, right? We're putting these trees in and we are not giving them success to live. And this is why, right? We have very hard, compact soils a lot of times. We stick the box or the tree in this kind of area, compacted soil all around, root ball. There's no room for that tree to grow. So what else is it going to do except for struggle and then probably end up dying? We don't want that. We don't want that. We do want this. So we luckily have tools in our toolbox to achieve the more nice canopied looks. So I'm going to go into just some overviews here, and then Evan's going to get into more details about these. But some general practices that we'll see are tree boxes, suspended pavement systems, and I will also touch on structural soil. I think it's important to understand what it is. I do not recommend it as much for most areas, and you'll see why coming up. There's a really good study on that. But our goals are really just that space for tree growth in an urban environment, preventing that root heaving, so upheaval of sidewalks, helping to collect the stormwater, reducing the nutrients from stormwater, and also creating this beautiful urban canopy that has all those benefits that we just talked about. So first, we'll talk about structural soil. Pretty briefly, it's an engineered soil. And when I say engineered, what I really mean is it's specially mixed, right? Specially mixed with certain components in it, combinations of sandstone, soil, compost, depending on the different type of structural soil that it is, it'll have different percentages of each. But essentially that goal is to maintain these spaces. So instead of having compact soil where it's hard for water to infiltrate, and it's also hard for aeration and all the things, all the solutes that plants are going to need and trees are going to need to grow, it's hard to get through that compacted soil, right? It just kind of runs off in that case. So structured soil is really going to help to kind of maintain those spaces so that water and solutes, et cetera, can make their way through, create some area for roots to grow. So essentially what you can see here is that, with a stone one, you're going to have the stone particles, soil particles in between. So there's those areas for everything to get in where it needs to. You can see, though, what we'll compare this to is going to be the kind of engineered products that we'll talk about next. So our soil cells are, or also known as suspended pavement systems. So these are going to be modular underground systems. A lot of times these are made of plastic, LDPE, recycled plastic, which is great as well. They will be mixed with soil. So you can see here, you know, a couple pictures have these empty cells, and then you can see the soil actually going into those. So the job of this system, this modular system, is going to be to essentially hold space for the tree roots so that they can spread out, which means that we're having more increased success with our tree growth. So, and I don't know if you guys can make it out, but in that center picture, there's a couple holes there. That's where the actual trees will be planted. And then again, the roots are going to spread out underneath. The voids will be filled with soil. Okay, and the soil mix is usually also going to be a special mix to make sure that there is still space within that soil for everything that needs to get through. Now, you can use these underneath parking, underneath walkways, roadways, etc. So that way you're maintaining a very safe structural surface, right? Again, though, you're keeping that space for the roots to grow. The other great thing about these kinds of systems is that they're modular, they can move around utilities. Really important for those urban areas. And you can see that in that lower left picture. And just to give kind of a schematic of what that looks like underground, you can see that diagram there. And real life, you know, improving plazas, having this great tree grow there, because we want to have this, we want to be able to eat, sit outside, eat under the trees, etc. So the picture on the left is a picture of an actual implementation of a suspended pavement system. We can also see very successful canopy growth. So if you notice on here, we can see the growth from 2018 to 2021, right? So great canopy growth. Actually, this is really fun. And this is in, it's called Levy Plaza. It's in New South Wales, Australia. If you put that in, it's Levee. If you look that up on Google Maps, it's really fun. You can actually walk through the plaza and you can search through the different years and see the tree growth over the years. So I suggest doing that if you want to kind of be awesome and be a tree nerd like I am. Now, tree boxes, these are going to be more modular defined spaces. So we're going to be looking at different species when it comes to these guys. And Claire is going to talk to that later on. But we're looking at these more defined spaces with concrete walls. We can kind of make use of those more narrow right-of-way areas in this case. So we can do that. We can have covers on top. They can be designed for specific goals. So whether you wanted this to be kind of an inline feature, offline, have some kind of peak flow diversion here. We can expand these into an underground vault system too, so the water can kind of filter through and then go into another underground storage area. So different ways to design those that Evan will talk about as well. But you can see the difference here, right? These are, again, more compact linear spaces, run anywhere from about 4x4 to getting like really large ones as well, you know, 16 feet, 8 feet wide, things like that. Now I'm going to go into this Bartlett Tree Lab study, which I thought was extremely interesting. You can see the overview and the kind of lab setup here. Essentially, what they're going to do is compare different things. They compared normal soil, compacted soil. They compared different types of structural soils and also soil cells. So essentially, they created two 90-foot trenches, as you can see here. They used wood around the outside to separate those areas. Each area has about 42 cubic feet of soil in it. It's 2 feet deep and 5 feet wide. They are also lined to prevent the root growth outside. They wanted to keep everything very controlled in this study. So I'll put up the results here and kind of talk about it. So essentially that I put them in order, from least performing to best performing. So what they measured were these trees, and by the way, they're tulip poplar trees, but what they measured was not only the height and growth during the study, but also the canopy spread, so the width. And you can see that compacting that soil is no good. That was the compacted control is about a 95% compaction on the Proctor scale. So this is the 95% that you actually need to have things on the surface, right? You need to have drivable surface, etc. So again, that's what's done typically to our trees. This is why they can't grow. They physically cannot spread out and grow. Gravel-based structural soil you can see next at a 13-inch height growth and a 5-inch spread. Sand-based was next. But we looked at our control. So again, just typical soil, we had a 22-inch growth. So this is kind of where, that's even better. Regular soil is even better than structural soil. However, when we're in these urban environments or environments that are inhabited by humans that need to use the surface, we need to have some kind of a structure there, right? So we can't just do the normal soil a lot of times. However, our soil cells, those structural or suspended pavement, I should say, systems, they had the best height growth and spread of growth. So 35 inches in height on average and 27 spread. And just looking at a real world example of the two. So I'm just going to compare soil to structural because that's, the difference here is what we want to use a lot, but we can take the same environment. And this was one Main Street program where down the main street, they use the soil cells. And in order to cut costs down the side streets, they use some structural soil. So you can see the difference in growth. This is in the same exact area. And another one here, this one's is even better because they actually did compare, cost wise and everything, kind of like that New York City tree program is doing. But this was in Canada. It's a 15-year study. So essentially they're comparing a conventional approach of sticking the tree in the ground. There's compacted soil kind of all around. And then we have the soil cell growth. So essentially what they noticed, of course, this is after 15 years of conventional approach, that tree, 15 years old, they put in $650 each for these trees, for labor and the tree, okay? So $650 each, that's great. But they're valued because of where they are is only 510 each. Now, the soil cell solution, we can see this is what it looks like after only 4 years. Now, it was more expensive to install, a little over $10,000 per tree. However, just after 4 years, you've actually increased your return on investment. They're valued at $17,500 each for those benefits that we've talked about before. And just to see a comparison of the two, so the yellow is going to be the open ground planted trees versus trees that are planted in soil cells, giving them that space. Again, you're looking at, the middle of a parking lot. So there's lots of space for those roots to spread out underneath the parking, right? So we're going to take use of what's under for our trees and what's over for us. And you can see that difference in canopy as well. This is all I have. I'm going to hand it over to Dr. Eben Bean to give you guys the more specifics on design.
Coming right up. All right, well, good morning, everyone. Had to check my watch there. So I'm going to pick up basically where Jessica left off and continue sort of our discussion here. With these technologies, suspended pavements or suspended concrete pavements and tree boxes, we're trying to leverage the benefits to hydrology that trees provide, at least from a stormwater context. So the main ways that trees are providing this value. Am I sharing the correct?
It looks like it.
Okay, all right. Where things popped up on my screen, it looked like it was maybe on the wrong side. So anyway, so trees provide several functions here that we want to take advantage of, or we're trying to integrate into the urban environment. The first is that it reduces the effective rainfall via the canopy interception. So Jessica kind of touched on the leaf area and that basically capturing rainfall. So there's a certain amount of depth. It's not a tremendous amount, but at least there's a coverage or an interception over the canopied area that is essentially held by the leaves and then evaporated back to the atmosphere between storm events. So that rainfall doesn't make it to the impervious surface below, so we reduce the actual rainfall and thereby the actual runoff. The second function that trees provide that we're trying to leverage is transpiration, which is essentially the taking up of soil water back into the atmosphere as water vapor. And so we're utilizing this to help recover our stormwater storage that is in the system that we're trying to leverage here. And as Jessica noted, we're trying to also do this while achieving the benefits that are non-stormwater for trees, right? So we see these success and more like failures of street trees in many cases, where Oftentimes, due to compacted soils, we are limiting that root volume, and either the growth of trees is stunted and not able to really access much of the soil around it, or there's not enough water and nutrients in the soil due to either impervious cover or the compaction not allowing roots to get further out into the soil. So that limits the health and thriving of the tree. So these are some important things to keep in mind with the integration of these systems. Number one, we can't have compacted soil, right? We've got to have enough soil volume for the trees to be able to put out roots and pull in enough water and nutrients to thrive in their systems. So I'm going to start out a little bit with suspended concrete pavement systems. In some places, you'll find these termed tree trenches. And if you think about that terminology, this, it should kind of make sense how we are kind of integrating these. You're essentially creating a trench along these right-of-ways where stormwater can be directed, infiltrate into the media, and then all along that we have trees spaced every so often. They function very much like your typical subsurface retention or detention systems. We're sending stormwater below grade, below the pavement surface. It's infiltrating through some media and then either infiltrating into the subsurface as retention, or it's being filtered and collected by an underdrain that then ties in the filtered stormwater into the major stormwater system. So with these, because there is subsurface functionality and infiltration, one of the main things is pre-treatment. This is going to be critical to keep debris and any other material that could eventually clog that infiltrating surface or the hydraulics of the system, to keep that out of the system. And we'll kind of show some different configurations and ways that can be done here in a minute. The media that is added in, which is a little bit different from our subsurface detention systems, this media is added to enhance pollutant removal to help with particularly nutrients. And as Jessica alluded, that might be able to be engineered or specified for certain pollutants. And then, as I kind of alluded to earlier, trees are added in to help with the recovery of that storage volume, or the amount of water that is being held by the system, and to put that water back into the atmosphere. We also get the co-benefits of shade and cooling that we like with urban trees. Some of the nice things about this, it's been somewhat touched on, is the flexible geometry here. Because these open cells or soil cells are modular, they can be integrated into some pretty unique geometries and pretty well suited for narrow right-of-ways where, maybe it's even the space between the sidewalk and a roadway, and they're really well suited for retrofits. So just want to show a couple options. This is a unit called Stratovault. I believe this is a product that there's a couple different products, and we're not promoting one or the other, but just to kind of show you sort of some of the variations in the design, the structure, so that you can kind of see how they are similar and compare them. They all kind of function the same, and the importance of this component to the system is to essentially transfer the load from the surface, whether that is foot load and concrete, or maybe it is vehicle loading, down to the subsurface without compacting the soil that is between those two layers. So this is Stratovault. It's modular. You can see sort of 2-3 levels here, and porous water able to move through the top, and it's got an open bottom. Very high volume of porosity for soil to be filled in. These are Silva cells, another sort of similar product used essentially for the same type of application. The dimensions are a little bit different. They kind of get installed a little bit different. Still modular. You can see the dimensions that we have here, but essentially same function here, trying to basically transfer the loading from the surface down to the subsurface and provide quite a volume for soil in there. So typically with soil cells, these are going to be installed over a bed of gravel. So there's going to be an optional underdrain within that bed of gravel. So if if the soils are favorable and we don't have any limitations, we can infiltrate that water directly on site. But if there's an underdrain, or if we just want to make sure that we have redundancy to transfer that water downstream, if there is buildup or backup of water, we can include an underdrain. You can see sort of the underdrains nested in here with the soil cells. This is also kind of demonstrates pretty well how you can integrate or basically put these cells in around existing utilities, as Jessica kind of mentioned. Below that, you might have a liner in some systems if there are reasons not to infiltrate the soil, soil contamination issues, high water tables, other issues there. You can treat this basically as a detention system. And then we do have a compacted subbase below, sort of that 95% proctor density, so that we are able to support that over that loading at the top. So once this is put in, then we basically backfill with a bioretention media. These systems actually function very similar to bioretention if you're familiar with how they work, and the variations on their configuration analogous to bioretention. I've even seen this described in some ways as a subsurface bioretention. All right, so if you have a bioretention with a tree, and then we basically are able to put pavement up and around it, basically having the same functionality here. Okay, so it's not a extremely unique, completely different principle for operation and functioning. Water comes in, it's typically distributed through a surface pipe that I'll show you in a moment. Water then distributes throughout the media. It can build up on top of it, and then there's an underdrain that's optional to help recover that if we need to. Just wanted to show sort of a schematic that I think highlights a couple of different aspects here. Number one, we want to make sure we usually have an inlet that comes in, and then there is a distribution pipe that is either at the surface or just below the surface that allows that stormwater to come in and basically distribute across the surface of the engineered media. Notice that there is a gap between the top of the soil surface and the overlying structures, whatever that is. This also helps with the preventing roots from migrating to the surface, all right, and creating those types of issues with basically unsettling the surface pavement. Then down below, we have sort of an underdrain that collects that water. Sometimes this is actually in the bottom of the soil. Other times it's in the gravel subbase. I've seen it sort of done both ways. But essentially that just needs to be connected to the downstream system. Anytime that there is an inflow from the street, again, I just want to emphasize the importance of having some type of a pretreatment or some type of a structure that is going to collect any of that material that would potentially lead to clogging of the piping system or the soil itself. Because once that happens, it becomes very difficult to restore that. Just another kind of graphic here to kind of show sort of the way that we're looking at this from a cross section. In some cases, we have, for example, the catch basin going directly into the distribution pipe at the surface, and then the underdrain basically coming out. This also shows sort of a direct infiltration through a permeable pavement system. I'll show you a little bit more about that here in a little bit. But it really kind of shows sort of the ability or the breadth of the roots to be able to expand and fill that void space, take that water up and help to recover that volume. Denver is one of the few places that has some specific guidelines on these types of systems. They require an inlet pretreatment sump and filtration through the basically a number 8 stone. So if you see over here on the right, you can see this is sort of the inlet where the stormwater comes in. We have the number 8 stone here to filter that, and then the water makes its way through the distribution pipe. It actually distributes it as a through the sorry, it actually distributes it through the system this way. They also, the water then basically rises up from underneath and then will drain back down. It's controlled by this downstream control structure. And they use sort of a what's called an agro drain to basically control the discharge of this. They also have a requirement to release that water quality volume in about 12 hours through, and you can design sort of the rate that this discharges out through the orifice control. One of the other things to note is that they have, in this case, the trees are kind of set higher than the media within the open cells. So it's a little bit of a different design here. And then they also have sort of the option of permeable pavements. And they have sort of a recommended spacing here between 25 and 35 feet between the individual trees. So things to keep in mind with designing is where to include that pretreatment, or to basically how you're going to trap some of this material that would normally be getting into the system and clogging it up. This can be done in a variety of different ways, but typically it's either a sump or some type of a grate or a catch basin insert, something that's essentially going to prevent that material from migrating downstream, but not block flow continuously. Essentially, when these fail or they clog or the inlet clogs, then you have essentially bypass down the curb. So usually when the inlet is along a street curb, water's going to be moving down, and if it's open, it will migrate into the tree box system or the suspended pavement system. And then if it blocks up or can no longer enter, then it will continue downstream or down the curb there. A couple of things that are also to consider here, if you have contaminated soils, if there's concerns about saltwater intrusion, brownfields, these kind of issues, you may want to include an impermeable liner, or if you want to prevent infiltration near building foundations or roads and making sure that there's no issues with water migrating into the foundations of those or the base for those. And then another consideration might be if you've got major issues with I&I, infiltration and inflow, not contributing additional water by lateral infiltration from the tree system into the nearby drainage network. This just kind of shows sort of the configuration and how we can align these in the right of way. Typically, we typically have that stone base on the bottom. This is on top of that compacted subsoil. We have the open cells filled with media. The tree roots tend to expand through that uncompacted soil to maximize the volume that it can take water and nutrients up from. And then we have sort of the surface layer here on top. And in many cases, these are all interconnected in this series of trees. So you have multiple trees in a line here, and you actually don't need as much volume. You need you can think the volumes are typically, if you have a single tree, you need 1,000 cubic feet. But I've seen recommendations where, because it's shared volume among trees, you kind of go down to about 750 cubic feet among the different trees. Sorry, for each tree. And then you can also include this with permeable pavement on the top here to where cars are able to park on top, or even potentially drive over top of it if the system is designed properly. This actually works as a really effective pre-treatment to screen out materials. So if you think about, permeable pavement is a filter at the surface, and as long as you're keeping that material from clogging the surface, you should have pretty clean water basically vertically infiltrating through the system into the subsurface below. And this is sort of a graphic of showing, we have an under drain that can go through the gravel as opposed to being at the bottom of the soil. So it's kind of a design or engineer's preference on that. I think honestly, it'd probably be better to have it in the gravel layer than in the soil layer, just because of the potential for particles to migrate into the pipe or the under drain if it's in the soil layer. So probably more of a better decision to include it in the gravel and let that gravel kind of choke the surrounding soil and prevent that from migrating into the under drain there. Want to kind of go through some, just kind of what does it look like with the construction here. This is a series of photos that I got from University of Tennessee and Ohio State, some faculty that were working on some projects with a retrofit, and it really did a great job of kind of showing the construction process. So this was an existing right-of-way that you see here between, you know, we have a sidewalk, we have the grass right-of-way between the street, and they're basically going to utilize the right-of-way. So to the inside of the sidewalk or the whole sidewalk area over to the street. So we began the construction, starting to dig up the soil to excavate this area. And in this situation, we've got basically curb and gutter, stormwater running down the curb, and we want to basically direct the flow into this suspended pavement system. The volume that they excavated here ended up being 4 feet deep. This is pretty typical when you think about sort of the depth that you have. So this is something to keep in mind when considering depth to water table. Just like with a bioretention cell or other infiltration practices, we tend to want to make sure that we are leaving at least 2 feet between the bottom of that system and the seasonal high water table, so we don't get the development of a groundwater mounding situation. In this case, they had 9 feet of width to work with. You know, they could have worked with much narrower section and then extended it longer to get the same volume, but they had, you know, 4 by 9 by 36 feet here. First thing, once they got that excavated, was to compact that underlying soil. So again, you know, it's probably not as critical in this case because of the sidewalk utilization of this space, but particularly if you're transferring vehicle loadings down to the bottom surface, you want to make sure that that's well compacted. If there is a liner to be installed, then you wanted to, that would be the next step here. Typically, this is going to be for some type of a detention system. You might have a primary and secondary sort of geotextile to prevent, you know, puncturing of these pond liners or impermeable liners. Next, we have the stone base, and so we screed this level and then compact that with three passes from a plate compactor. So that gets good and stable, and so that the transfer of the open cells, the structures, is transferring down to a solid base. We then install the frames and lay those out. The first layer, then having a second layer that is installed on top of it, and then actually I sort of went had these out of order, but we should have put the under drains within the first layer of those frames, and we want to place the gravel in between the frames to hold them in place, and then essentially locking the under drains in place by zip ties, right? So it's, you know, this pipes would then connect downstream to the outlet or to the storm drain system downstream. So then once we have the under drains in place, we put in, we cover it with the pipes with gravel, and then put in the first lift of media. We fill that, continue to fill that media up, and then we can put some gravel sort of right underneath where the distribution pipes would be installed on the surface of the media. This allows for even distribution of water throughout the media and really making sure that we're utilizing that full volume rather than just concentrating at the inlet, creating sort of a moisture gradient. And if there's an area that's saturated, the water can kind of move down much more quickly and distribute throughout that volume. So next we fill up, or we put the, you know, we cover up the gravel. In this case, it's just below the top of the media with the aggregate or the stone on top of it, and then covered with the bioretention media. Important to, just like with the under drains, to kind of anchor those pipes in place. We use zip ties in this case. And then, you know, we have the deck frames that are put on top. In this case, they were using Silva cells, would have been the same process essentially for the stratovolts. And then we fill up the media, in this case, up to the upper frame. Because they were using an impermeable liner, they put that over the top here just to and it was partially because of a research study that was going on. You can see the clean out that was installed here, just to kind of be able to make sure if there are any issues with the under drains, we can get in there and be able to restore that. So once the top is basically completed and finished, they can put in the stone base for, remember they were using this as a sidewalk area. So they basically are restoring the base of that sidewalk. And then you can kind of see how this is completed. This is the street tree that was put in at completion or at construction. And you see the sidewalk on the right and completely underneath the surface. It's a little bit out of frame, but you can hopefully barely see just in the bottom left-hand corner. That's where the storm drain inlet is going to go into this system to capture the stormwater runoff from the streets there. So using permeable pavement as an inlet or kind of a maintenance protection technique, or basically a screening pretreatment system is an effective way to utilize these two practices. It definitely guarantees the removal of those gross solids at the surface. And essentially, we just need to make sure that we are cleaning the pavement material on a regular basis of any material that would clog that entrance, that pavement. You can see sort of a couple of figures here, whether it's just the permeable pavement, the permeable pavers as like a trench on the left that's in between the car stalls, or it may be that the permeable pavement is over the entire system. And when we're using this, we don't necessarily need to have the distribution pipe because the infiltration is occurring all across the entire pavement surface when the surface is completely permeable. Just another example of where this has been implemented, and keeping in mind that you don't need to have the entire parking area or impervious area be permeable. So we have sort of a non-permeable section that drains to the permeable, that then infiltrates into the ground and then supports some of the trees that are in the islands here, and that they are able to take up the water and put that into the atmosphere. Moving right along. So moving on to tree boxes and tree wells, tree filters. So here's an example of a tree box combined with permeable pavements on the left with Celebration, that's in Celebration Point here in Gainesville. Parking stall all around this tree, but a tree well or a tree box kind of here in the middle that is helping to take up that stormwater that has infiltrated. On the right, we have a general schematic that FDEP has produced that shows sort of the typical configuration or sort of a conceptual design of what an individual tree box might look like. And in this case, we have what we would refer to as a tree well, and get into it a little bit more, but there's some different variations on the design of the tree box. Essentially, very much like the suspended pavement, we have stormwater coming off the street. We have water then distributes over the top of the bioretention media and then infiltrates through that media into a gravel stone aggregate layer down below. And that can either infiltrate into the subsurface or be collected in an under drain that can then direct that water to the downstream stormwater system. The water that is retained in the soil, this is typically, we call the plant available water. And trees can basically take up this volume and restore that volume or that storage capacity in between most storm events. A couple of things just to kind of describe and put this in context. The tree boxes are essentially analogous to the modular suspended pavement systems. They're essentially a modular unit of that. So instead of having sort of a flexible design that the suspended pavements provide, this is kind of like you order one and you get the box, it goes in, it's precast and delivered to the site and goes in. Again, we typically use a bioretention media or some other similar type of media here. It's commonly used in parking lots, easy to use or put in place with retrofits. And then we use the term tree box filters if it is a detention system that basically just filters the stormwater. So there's no open bottom, it's closed, and there would be an under drain to help recover that additional volume. And if it is an open bottom that allows water to infiltrate into the ground, we would call this a well. So think about a well being able to contact or infiltrate to the groundwater. So if it's open bottom, tree well, and this provides us with retention and infiltration. just some images of what the tree box kind of looks like. So just to kind of describe what you're seeing here, you have sort of the main volume of the box. And if you look on the left, you can see there's an opening at the bottom. So this would be a tree well. And this can be installed with, it can either have sort of solid sides, or it can have openings to connect with other tree wells or tree boxes to have more cumulative volume of storage. So that's the main volume. And then each of these sort of has a smaller inlet box, and that's essentially a pre-treatment sump. So any of the large coarse debris and material would essentially get caught in that to prevent clogging the system there. And the main thing is that these systems, you just need to clear out that sump or that collection of that debris on a regular basis. This is what these look like when they're installed. And so you can see sort of here's the main tree box volume with the tree planted in place. Here's what that sort of pre-treatment sump, we got a typical grate that goes over top of it. And this is a situation where we have 3 of them in a row. So we might have sort of the sides sealed together so that stormwater comes in on either side here, but we're able to utilize the volume in between those and sort of laterally distribute that water. Maintenance, again, just like for the suspended pavement systems, this is critical to making sure that they continue to function. We want to make sure that the coarse debris, particularly leaves that may be coming from the trees, are kept from kind of getting into the system, clogging it, caking over the top of the system. Making sure that we are able to keep out sediment, leaf litter, woody debris, a lot of gross solids. I just can't emphasize anymore. Just maintenance is critical for these systems. There are some different configurations with tree boxes. I think these are actually some examples of storm tree, if I remember the reference, but you can see the configurations that have different ways of including pre-treatment or different configurations. So here we have sort of just coming through the gutter and throat inlet, water distributes across the surface, infiltrates, and then can go into an under drain. Here we have an inflow pipe that can come into the side, or we have sort of the typical throat inlet with the pre-treatment sump. Both of those would come in, any debris would be trapped here, and overflow of cleaner water would happen here. And then here, you don't necessarily have to have an inlet at the street. It could be just a straight pipe going in here under the surface. If we have a roof drain, keeping in mind that roof runoff tends to be much cleaner than your typical roadway runoff, particularly when it comes to debris, we can basically route that water directly into the system here. This has a side entry with pre-treatment sump, and you can have this basically just attached to a catch basin. And this is sort of the integrated approach that we saw in some of the previous pictures of the installation there. So a variety of options there. But again, just to reemphasize, maintenance is critical. Just a plug here, we have developed a GSI maintenance training course for those professionals who would like to learn about the maintenance that's necessary for keeping GSI functioning. It is intended to be for the landscape program, and Claire Lewis and myself have worked to develop this. We have a few different resources. One of them are inspection checklists, and we have a draft of an inspection checklist for tree boxes and tree wells. And essentially the main principles for maintenance are to maintain flow. Again, we want to avoid bypass. We want to make sure that water is moving into and out of the system. So making sure our inlets are clear, our storage is able to recover, and our outlets are clear as well. And then checking for the health of the vegetation. It's kind of difficult to determine how effectively a system is working just by looking at it from a water quality standpoint, other than gross solids and sediments. So we have to kind of rely on the understanding of, okay, if the system is functioning as it's designed from a flow perspective and the vegetation is healthy, we're providing the best opportunity for these functions to occur that it's designed to do. Okay. All right, and at this point, I will turn it over to Claire Lewis.
Thanks, Evan. I just wanted to jump in and say, I saw we had a few great questions from our participants. We're going to move on to Claire's presentation right now, and then we'll get to those questions during our Q&A at the end of the webinar. Thanks, everyone.
Okay, hopefully you can see my screen okay. Are you seeing the correct screen for me? If someone could just verify. Can all right, I'm gonna try again. Okay, I
Looks
assume
great.
you guys can see, it's not showing up on my end where you usually get a box around it, but we good?
I had the same thing, Claire, and I think it looks great.
Okay, thank you. It's a little discerning. It's like, all right. So I'm really happy to be here today. I'm gonna talk about some of the benefits of trees and some considerations to keep in mind when you're selecting trees for these sites. I'll review just a little bit of some of the information that Jessica gave and hopefully expand on some of that. So mature trees provide a significant stormwater benefit, as we've heard all throughout today, for storage, interception, and evapotranspiration. You can kind of think of tree canopy as a giant sponge in the sky. They're really the first line of defense in capturing stormwater. And as our research has shown, the small storm events are responsible for most of the annual pollutant loading that we see. And this is precisely where the trees, these street trees that we plant, are most effective in intercepting and capturing this rainfall and capturing these pollutants. So they can be a great first line of defense. And when tree planting areas are designed and engineered with healthy trees as a goal and not just as an afterthought, trees grow to their maximum size, extending dense canopies and providing the greatest stormwater benefits to our cities, as well as other environmental benefits. And these include improving air quality by reducing carbon dioxide, absorbing ozone, reducing particulate matters in the air, such as dust and smoke, and increasing oxygen level. Also, they improve water quality, as we've been talking about. They filter and reduce stormwater runoff, and they promote infiltration of the water into the ground by allowing, the roots allowing the water to seep in. They also can help in saving energy. They reduce the urban heat island effect, and they can help cool the air through transpiration. They can also help increase property values, and they do this by adding beauty to the landscape and creating a sense of place. They provide ecosystem services and habitats for wildlife and animals. And trees have even been shown to reduce crime. So now that we know all the good things about trees, well, let's talk about a few of the site constraints that we may see. Really the suitability of a site to support healthy tree growth in urban areas is one of the most challenging aspects of what we're doing here. With all the different things that we'll talk about that can interfere with the tree and tree growth, you really have to, do.
Excuse me, Claire?
Yeah.
Sorry, I don't mean to interrupt. We have some folks that are having a little trouble hearing. Is there any way we might be able to adjust the audio? I think if you see the mute unmute button and then click the arrow next to it, it'll bring up a little box, and one of them says audio settings.
Okay, I can check. Does this help?
That sounds a lot better to me. Yeah.
Okay, sorry about that.
Awesome. No worries. Thanks.
I usually talk so loud that I didn't think that it was going to be an issue.
No
but
worries.
I guess I'm not shouting at everybody today. So, okay. So the suitability of a site to support healthy tree growth, as I said, is really one of our biggest challenges. And some of these challenges include, of course, space requirements, having the tree having a large enough space to grow, as we've talked about, the soil quality and texture. Steep slopes can be an issue, especially for irrigation and long-term kind of maintenance issue. And of course, overhead and underground utilities are a big issue. So, when, evaluating your site, you should, definitely note the overhead wires, any structures, signs, or lighting that exists, other trees and underground utilities, as well as other hardscapes that are around it. And you also want to take into consideration the mature size of the tree to make sure, to account for any potential future conflict. Another thing to keep in mind is you need to check with local ordinances for setback requirements between trees and infrastructure. Those ordinances could be, either from the utility company or from your municipality. So, make sure you're aware of what codes are in effect in the area. Some other things to keep in mind is, proximity to structures such as buildings and things like that, and other impervious surfaces. And then some other, less tangible challenges, but still very real challenges are things like pedestrian traffic and vandalism of our street trees and our streetscapes, the high temperatures from roads and sidewalks and things like that is really stressful on our plant material. Trash accumulation happens, around the trees at the bottom and also up in the branches and things like that. Sight lines and visibility for both, turning radiuses and businesses. They want, they don't want things blocking their signs. So that can be a consideration that sometimes we have to work around. And then, of course, any ADA requirements are also can, need to be factored in and can sometimes be a challenge. So this graph here is pretty interesting. I think this was developed by Dr. Ed Gilman for recommendations for planting around wires and security lights. So basically, you don't want to plant, 6 feet or less next to any kind of power poles or lights. And then if you're outside of 6 feet, you can plant 10 feet or less from the height or width of the tree. So in this example, we'll say that this power pole is 30 feet high. So a 20-foot high, a small tree that grows 20 feet high would be, that tallest tree that you could get into this small space. If you had more room to plant, you can plant a larger tree. And we could say that this is maybe a red maple that has a 30-foot diameter. So you would have it, 15 feet plus 10. So if you planted that tree like 25 feet away from that power line, that should be adequate. But it's just a good graphic reminder of how to avoid, these conflicts with utilities. Another table that was developed by Ed Gilman is on soil volume. So there's been a lot of research done to determine the relationship between soil volume and mature tree size. And I think just I had some of the best pictures I've seen. Those were really great slides on the trees with the soil cells. But so although there's not a universal standard for soil volume requirements, it's generally accepted that 1,000 cubic feet of uncompacted soil is what's needed for a 16-inch diameter tree. So it's 16-inch DBH, so diameter of breast heights needs at least 1,000 cubic square feet of soil. If you go bigger than that, a larger tree, of course, are going to, really prefer more soil. So 24 inches, you could say, 1,700 cubic feet. And this soil should be at least 3 feet deep. And when possible, move that tree as, far from the hardscape as possible. So those are some general, guidelines for soil volume. And next, we're going to talk about tree selection and installation. So some things to keep in mind. So, as I've said, urban environments can be harsh, and proper tree selection will save money in the long run through lower maintenance costs and also, hopefully less replacement cost of that plant material. So you want to take into some consideration, of course, the hardiness zone. Will the tree survive there? You want to look at the wind and salt tolerance. Those can be real issues for our street trees. Of course, the mature height and width. The growth rate can sometimes be a factor if you want, a faster growing tree to provide more immediate shade, or if you're looking for, a more slow growing tree that you might not need to prune as much. So those are things to keep in mind. Also, the ornamental traits of the tree, does it flower, or does it have interesting bark, or, is it deciduous where, in the winter it will, allow for the sun to come through and warm you, but in the summer, it'll stay nice and cool. And then also any kind of, benefits to wildlife or habitat are also some things you might keep in mind. And, just one other thing that I would like to say is it's also important to use a diversity of trees. And I know it's there's a fine line because you want to keep some consistency in your street trees, but you need to have a diversity as well, because when we have things, insects or disease outbreaks, it can really just wipe out your, all your plantings if you have a monoculture. So we're seeing that right now. You may have noticed it with some lethal bronzing that's going on with palm trees, and we're losing a lot of our palm trees to this new pest. So just something to keep in mind as you're selecting trees. And to help select trees, we've developed, as Evan mentioned, this Green Stormwater Infrastructure Maintenance and Planting Manual. And we have a list of appropriate tree and plant species, their growing requirements, and these are all really to help you select the right tree for the right place. The document's in final review right now, but it'll be posted to our website and also to the Green Stormwater Infrastructure website that Evan showed earlier. The plant selection guide has some interesting things. It talks about plant spacing that you might not see all the time. Things for like bank stabilization or erosion control, which might not be applicable to, tree boxes and street trees, but for certainly other green stormwater infrastructure systems, it's a really good, thing to have included in this manual. Tree box sizes is something that we get asked about a lot, and this is from Ed Gilman's research. And basically, large trees, you need an 8x8 box at least, planting area. Medium-sized trees need at least a 6x6 area, and small trees would be 4x4. So that's just something to keep in mind as you're designing. We have outlined different plant material that will work in each of these boxes. So it's in that manual that we've been referencing. So you can see there's a list of trees for the small boxes, large boxes, and medium boxes. So there we go. Some other things to be aware of when selecting urban street trees are you want to select trees with good quality trunk structure and branch arrangement. So on this image here on the left, you'll see that there's a nice central leader going up the middle and an even branching pattern. This is desirable because it makes for a stronger, more resilient tree. When you have things like codominant leaders that you see on this one, there's more likely to be breakage of the tree branches, and just it's not as healthy and structurally sound of a tree. So you do want to look for that central dominant trunk. You want to avoid planting pot-bound plants or plants with circling roots. And that's what this image up here is showing. So the plant was pot-bound, and then this is a circling root. And as this tree trunk grows and the diameter gets bigger, it will end up getting, kind of girdled by this circling tree trunk, and the tree will eventually die and just kind of fall over as a result of that girdling. So that's where, having good quality nursery stock is important. And if you see something like this, sometimes you can cut that circling root, and other times you just need to ask them to bring you a better grown tree. You can also consider installing smaller trees or younger trees as they take less time to establish. You don't have to water them in quite as long. So smaller trees you don't have to, baby quite as much as you do some of the, larger, 4-5 inch DBH trees. Another consideration to keep in mind is the amount of leaf or fruit litter that a tree might produce. So depending on, what your maintenance budget is, you may need to be able to do things like, have a street sweeper or, sweeping the sidewalks to make sure that the fruit from the tree doesn't fall on the sidewalks and cause like a trip hazard or something like that. So just be aware of what, of what the fruiting and leaf patterns are. Leaf litter also, just something else, leaf litter also may contribute to nutrient loading. So if you're in an impaired watershed, you might not want a tree that has a lot of leaf litter if you can't get that swept up. And it's something else to kind of keep in mind is, in this tree establishment is we don't generally advise to use soil amendments in the planting hole when you're first installing a tree. The reason why is that this rich soil kind of discourages the roots from extending into the native soil and really anchoring it down because it's real happy with all the nutrients it's getting. And it, ultimately you do want the root structure to reach into the native soil and anchor the tree down. So unless the soil is extremely poor quality, don't add nutrients, to that soil when you're planting it. So next I'm going to talk about tree establishment and maintenance. And I'm going to start off with the irrigation needs, the watering needs of that tree. So this table is a great table to just, have in the background. And we can share these slides too, but so what you want to do is you want to irrigate 2 to 3 gallons of water per inch of trunk diameter. So I'm going to say, usually when I spec trees, I usually spec a 3-inch caliper tree. So I'll say 3 inches. And so for a 3-inch tree, it should be watered with 6 to 9 gallons of water every day for a month. And then after that, every other day for 3 months, and then weekly until established. And according to this guideline, that tree should be established within about 12 months. So this is just a really good synopsis of how much to water trees and for how long to water trees. Some other things, we have this included in the manual that we've talked about, but like a maintenance schedule, some things to keep in mind. For summer, you want to make structural repairs and remove any buildup of weeds or debris. And it goes through all the seasons, so you can kind of look at that, like pruning early in spring. But what I want to talk about with this image here is, and it's really making the structural repairs. They never adjusted the tree grate as the tree grew in. So this tree grate actually girdled the tree and killed the tree because they never adjusted the bands out to allow for the growth. So, speccing tree grates that can be modified is important because this is, certainly not what you want to happen to your trees. Okay, so next I'm going to talk about some potential issues. And streetscape designs and individual tree planting spaces often fail to address the needs of the tree. Like they're put in because it's a streetscape and they need a tree, but they're not really thinking about the tree itself. And when this happens, the tree may show signs of decline, and it may present an increased risk of like limb or tree failure, which can lead to liability for both, the pedestrians using the site, and then also as a professional liability. So these declining trees are removed because the tree was the problem. However, in reality, it's really the site design that was the problem and not the tree. The cost of removing and replacing this tree is a significant investment, and it's a waste of the community's money and time. And it could have been prevented with proper design. So just, these are, being responsible in our tree selection and how we prepare the planting area for the tree is really something that I think we all need to keep in mind as we do these landscapes. So there are a lot of things that impact a tree life expectancy. And, one is for site conditions, like the one shown here in this image. This was a really wet site. And this is one of those things where the roots never, set into the soil because the water was just so, the soil was just so wet. And the tree just eventually rotted and had to be removed. What we looked at earlier with the circling roots and things like that, substandard plant material is one of the things trees die. Unresolved compaction and drainage issues are also, as we've talked about, a big issue. And staking can also become a problem. And as you'll see here, the tree stake material was just never removed. This is a good material to use for tree staking, but you gotta, once that tree has established, you gotta remove the tree stakes so you don't girdle the tree that way. I have another image here. So this picture is an example of compacted soil limiting the root establishment of the tree. So large maturing trees can become unstable in high winds due to a shallow root system and compacted, poorly drained soils. So this was after a storm event, but you can see that the tree these trees never really, never really secured, anchored into the ground. And when this hurricane came through, it just simply blew them over, and there was nothing holding them down. So I realize this isn't a tree box, but you can imagine it in a tree box situation as well. Soil quality and texture is another big issue, and the lack of organic matter in the soil limits the amount of water and nutrients available to the tree roots. High pH from building materials such as stone and asphalt and things like that contains calcium, and that can limit tree growth. Compacted soils that we've talked so much about can slow root growth and not allow the water to seep into the soils. And also, you want to be sure to evaluate that soil for compaction. So if it is compacted, you need to till it or add soil amendments. So there's things that we can do to prevent this. This is an example from an IFAS document of bad street tree design. So these are large street trees that are just really planted too close to the building, and they're in very small planting areas, as you can see. This is an example of a better design. Certainly the trees are out from underneath the canopy. And then this is also, they have the holding cells underneath here, like we saw earlier in Evan and Jessica's presentation. So these trees have a much better chance of living and really thriving in that environment. This is an example of street lighting. So trees and street lights are often located in the same general area. And some things that you need to keep in mind is that you want to plant trees, certainly best is, if you can get them far enough away from the light structure so that they don't interfere with each other, or, have a pruning, plan in place if, you can get that tree up above the light structure. All right, so this is what I'm trying to say. If you have smaller street lights, like for pedestrians, you can have a tree that grows over those lights. But when you have these street trees, like, these street lights, then what you need to do is have a smaller tree and spaced away. I hope that makes sense. I don't think I explained that very well. But just looking at these interactions in a different way. And also, there's a significant cost associated with having to, trim these trees away from the power lines. So, really best to keep the interactions as limited as possible. Next, I'm going to just talk about some resources available. And And I'll start with this one here. This is a great resource for municipalities to consider when making code regulations and on other, and kind of determining how much space they're going to allocate for trees to grow. So this is really just so that it's available, it's out there. The Green Stormwater Infrastructure website, which has just a lot of great information that we've mentioned today. I strongly recommend you go there and check it out. This is the GSI plant maintenance manual that we've been referencing. And this is similar, this iTree software is similar to the software that Jessica mentioned earlier. So it's a really great state-of-the-art peer-reviewed software suite from the USDA Forest Service that provides urban and rural forestry analysis and benefits. The iTree tools can help strengthen forest management and advocacy efforts by quantifying forest structure and the environmental benefits that trees provide. So you'll see on this example here, from 2009 in Orlando, Florida, 68,000 trees were analyzed with the iTree software, and it showed that these trees intercepted 283 million gallons of water a year in Orlando, Florida. And so I'm going to briefly show you, it's really easy to use. I just plugged in like one live oak at 3 inches, and this is the information I plugged in there. And then it tells you things like the energy benefits, fuel saved, electricity saved, things like that. And it also, if you go over here to ecosystem services, it shows you the amount of rainfall intercepted and the amount of rainfall avoided in runoff. So this can be a great tool for you to use as you're making your case for more street trees or bigger street trees, and why this would be beneficial to the city. Because once you start to plug in those numbers and your stormwater system numbers, I think you can really create a good case for trees. And then I'm ending with this really wonderful example of urban street tree planting. This was also by Dr. Ed Gilman, but he says the reason why this was such a successful planting is because and as you see, it's really only 3 street trees, and it creates just a really nice place that you would like to be, right? Like you can see, that would be a comfortable place to walk or sit down and rest. This was successful because they were given the appropriate soil space for root expansion, and the root systems of these trees were overlapping and have colonized that entire shared soil space. So the trees are happy, and I think that the pedestrians that are walking through that space are happy too. And with that, we have a few minutes for questions, so I will stop sharing my screen.
Awesome. Thanks, Claire. I want to thank all of our panelists today. I think we had a great discussion on tree boxes and suspended concrete systems. We have some great questions from our audience, so I'll go ahead and pose those to the panel and see if you can help answer them. So our first question comes from Elizabeth, who was asking, if a tree is planted within this type of structural system and the tree fails or dies and needs to be replaced, how easy is it to remove and replace the tree from the system without destroying the structural integrity of the system?
I can chime in on that. So if we're talking about the structural, like the soil cells themselves, you'd have to, it depends what's on top, of course, but essentially, if we're talking about a tree that's maybe diseased and sick or dead anyway, it's probably easy to take out. So luckily you have that wider space where the tree actually was planted. So the roots would have to be cut in that space and then pulled the tree out. The remaining roots that might have gone throughout the system can be left to just basically decompose and become part of the soil, and a new tree could be planted in there. So that would be probably the simplest way to go about that. And again, this is an assumption that it's not like some adult tree that something happened to. That would be a little more obviously spread out. So
awesome. Thanks, Jessica. And then our next question comes from Pat, who asks, how do you keep trees from drowning in a wettish neighborhood with high water table and lots of problems with oak trees lifting up sidewalks? I think mainly looking to learn about how you prevent drowning out trees and with a high water table and lots of water.
Yeah, I mean, so the recommendation is at the bottom of this, of an infiltration practice, is at least 2 feet above the seasonal high water table. Okay, so if we don't have that, then infiltration may not be the way to do that. If you still want to have a street tree in there and provide the filtration and the function of the tree taking up stormwater, we're integrated in the suspended pavement system, an impermeable liner can be put in, and with an under drain that will help to keep that soil not from getting too wet for too long. So that will basically recover that storage and allow that soil to dry out and it not become completely saturated for extended periods of time.
Awesome. Thanks, Evan. Our next question comes from Greg, and Greg's asking, what is an anticipated end of life for an installation in like the Tennessee example? I believe that was from Evan's presentation. What level of disruption to surrounding trees could you expect to update the system once ELO is reached?
Jessica may have some input on this as far as the replacement of the tree once it's kind of reached its end of life. You know, the difference, the tree end of life is going to vary by species, and that's something you can try and take into account doing the planning and designing, is looking at how long these trees typically live. Barring that there's no disease or any other issues that come up, we typically see that these systems can last around 20 years for the performance and functioning of it, as long as it's maintained on a regular basis. As far as the replacement, you know, if you notice the spacing of these, I believe that, you know, Denver kind of had a recommendation of 25 to 35 feet in between. And so if you're replacing a single tree, you should have a space of, 50 to 70 feet in between the two remaining trees to be able to operate and pull that old tree out that may not be doing so well. Just anything to add on that?
I don't. I was actually going to ask Claire for her tree input.
I don't really have anything to add to that. I'm sorry.
Awesome. Thanks, y'all. And then our last question today comes from Elizabeth, who is wondering about the viability of retrofitting tree well systems into an existing parking lot.
Yeah, it's absolutely a great option for retrofitting in parking lots, because you've got a very set geometry. And the only thing is just being sure with wherever that's going to wherever that tree well is going to go, just making sure that there aren't utilities that are going to conflict with it. And making sure that your soils, if it's a tree well, make sure your soils and your high water table are good enough to allow for that infiltration, vertical infiltration into the subsoil. So those are the main limiting factors, I would say, on retrofitting parking lots for the most part.
And I think it's good to take advantage of opportunities. So if there's a parking lot where construction is going to need to be done, or regrading is taking place, or something, resurfacing something, because when you do put in tree wells or whatever, you're going to have the grading so that the stormwater is collected there, right? The stormwater is made to move towards those tree wells, so it can be collected there. So I think it's definitely looking for those opportunities where if you have one that's already existing and you have this, like, something needs to be done, take advantage of that. It's a great idea.
Yeah, just to add on to that, made me think of something we didn't really talk about too much, was approximate cost or so with these systems. And you're going to reduce the cost with, if you already are, if you're integrating an installation of a suspended pavement system with replacement of utilities, or where there's already been some mobilization of equipment, you've torn up the streets, sidewalks, and so forth. Some of the literature that I've kind of looked at, these numbers may be a little bit dated, but looking at, tree boxes, trees in these systems might be, 15,000 per tree. That might be a little bit, your mileage may vary, so to speak. But the other number that I saw was somewhere between $50 and $75 per square foot with the tree systems.
Awesome. Thanks, y'all. We did have one other question to get to. I'm sorry about that. Before we get there, though, I did just want to let you know, in regard to retrofitting tree boxes, that is something that we are able to fund out of the non-point program here at DEP. So if you go on to the link I dropped earlier in the webinar, you can find information on our funding, and we do fund green stormwater infrastructure retrofit projects. So that's something to consider as well. And then this will actually, we got another question coming in. So first question is how to prevent, and I know this was answered through text, but we'll address it again. How to prevent trees from uplifting pavement and sidewalks. I think Jessica got to that one earlier, if you want to take it.
Yeah, I was just saying that basically these solutions that we're presenting, these engineered solutions specifically, are designed to either contain the roots like a tree box would, that's concrete on the outside, right? Or like the suspended pavement systems to actually direct the roots underground and to spread out underground so that they don't lift up. Because the main reasons, and I'm sure Claire kind of touched on all this anyway, but the main reasons trees do that is because they don't have the conditions they need, right? There's not enough space for them, or there's not enough water or aeration getting through. So providing them with that environment underground using these solutions prevents that upheaval from happening.
Yeah, I'll just, if you don't want me adding too, I mean, as the water moves down through this media, you get the water, it dries out from the top down. That's going to encourage the roots to go, down as to get to that water. And also if we keep a space or separation, a few inches between the top of the media or the top of these cells, or sorry, the top of the media and the pavement itself, that's also going to create sort of a separation that roots aren't going to come up into that void space and try and get water. There's not water there on a regular basis to do that.
Great. We have some more questions rolling in, so we'll do as many as we can before we run out of time. The next question is, can you please comment on how these types of systems can improve stormwater quality?
Yeah, well, for one thing, if you think about like a filter system, at a minimum, they do very good at particulates and sediments, removing those very well. If you have a retention system and there's no water that's going to be leaving the system, then anything that flows into that is going to basically stay on that site and it's going to completely remove that. So that's kind of depends on sort of volume. When you have a flow through filtration system, this is going to be about as effective as bioretention because we're usually using very similar structures of media. We can include some design media to improve removal of nutrients. And I think, Jessica may have something to add to that as far as the, targeting specific pollutants and so forth.
Yeah, I mean, you can add something like golden gold in these situations too, making sure that you have the right amount, of course, and everything in there. And then you can specifically target nitrogen, phosphorus in that case. And bacteria, if that's a thing for your area.
Thank you. So I believe we do have a hard cutoff time at 12:30. So we have 2 questions left. So just in case the call does get cut, I just want to make sure everyone's aware of that. I want to thank you all for joining us today. It's been a great webinar. So Susanna is asking, how do you retrofit areas with existing mature trees?
So I'm going to jump in, and I think that we would probably, if we have a healthy, large tree that is doing well, I think we would probably, we might want to try not to disturb that as much as possible because it is providing great functionality as far as canopy interception and taking up water from the surrounding area. So you could enhance maybe by providing some additional storage of capturing runoff and providing it close to maybe the perimeter of the roots. I'm not sure of that being a very common practice. But I would also have some concerns about, it's an old adage, but I kind of like it. I mean, if it's not broke, don't fix it kind of thing, like look for another opportunity to implement some strategies.
Awesome. Thanks, Evan. And then this should be our last question of the day from Greg, clarifying on his earlier question about the end of life of the tree. So he was actually curious about the end of life of the pavement system, not the trees themselves, and how much of its disturbance would there be to the surrounding trees when repairing the pavement portion of the system.
So I think this was in reference to that project that I was showing the construction of, and I hope that's sort of where you're going here. You notice one thing, when they installed the tree was actually coming out of the part that was not in the pavement area. So it's not going to be directly up against it. So if you have to re-put a part of the sidewalk and the pavement is kind of broken and failing, you don't want to, you're not going to really disturb the tree as long as you kind of don't make impacts with it above the ground, above the surface. So you remove the top of the top layers of concrete, there's still a gravel sub base there, and then you would replace the concrete as you would, with a typical concrete pavement system.
Great, thanks, Evan. Well, that concludes our question and answer. We had some great questions today, and I want to thank everyone for attending the webinar. I want to thank our panelists for participating today. I think it was a great discussion. Just a reminder, on May 18th, we will have our next webinar of the series, and there we'll be covering pervious surfaces. We'll have another great panel for you ready to go. So we hope to see you then, and just want to send out another thank you. Thanks for joining us.